Okay, section 2.8, price floors and ceilings. The first question is, using sketch notes, what is deadweight loss? So deadweight loss, when you're looking at a graph with a price floor or a price ceiling, you see where your initial supply and demand curve is at equilibrium. And when there's a price ceiling set, deadweight loss is the loss, consumer surplus and producer surplus from inefficiency. So in order to be efficient, the consumer surplus and the producer surplus would have to be maximized, and that just means it's not a mutually beneficial transaction with them. Moving on to the second question, using a graph, what is a price floor? Give a real life example. So in the case that there would be let's say a new video game, the equilibrium price determined by supply and demand is, let's say, $300. However, some retailers and other people who are selling it might sell it for $250 to attract more customers. And so to make sure that retailers maintain a minimum price, there can be a price floor that's implemented by the government, let's say at $320. So that would be up here. And this means that stores can't sell the game for less than $320. So this keeps prices high, but can lead to a surplus, meaning that not all of the games will be sold, and some kids or whoever may miss out on buying them at the lower price. Also, for a price floor, it's always above the equilibrium line. So a price floor is up here. So for question 3, I'm explaining what a price ceiling is with a real life example. So say there's a city where the demand for housing is really high, but the supply of affordable housing is low. Many renters are, say, struggling to afford their rent. To help keep housing affordable, the government could impose a price ceiling down here, right, this horizontal line, on rent. So say the average rent is $1,500 a month, the government can set a price ceiling of $1,200 a month for rent. Question 4, on a market graph, create a problem that would include an effective price ceiling and indicate the area of storage or loss, the amount of supplied, the amount demanded, the deadweight loss, and the consumer and producer surplus. So in this graph up here, you can see that there's a price ceiling set at $7, and the equilibrium price would be $10. The equilibrium quantity right here is 100 pizzas, because that's where the equilibrium is, the dot, and then comes down to 100. And the quantity supplied is 50 pizzas at $7. And the quantity demanded is 150 pizzas, which is over here at $7. Because that's where this interacts with the supply curve, and that's where this interacts with the demand curve. And then the amount of shortage is actually going to be this box over here, because the quantity demanded is greater than the quantity supplied. So the shortage would be 100 pizzas, because 150 minus 50 is 100. So looking for the consumer surplus, that's going to be this whole area up here, the area above the price ceiling at $7, but demand below the demand curve. And then the producer surplus is just this triangle right here, the area below the price ceiling and above the supply curve. And then the deadweight loss is going to be this tiny triangle over here from between the demand curve and the supply curve, these two, from the quantity supplied, which is the 50 pizzas, to the equilibrium, which is at 100. 5 asks how to calculate the area of deadweight loss. And so to do that, you would get the height of the deadweight loss, which is the demand price at quantity supplied minus the supply price at quantity demanded. And so the base of the deadweight loss triangle is the equilibrium quantity minus the supply quantity. And then the deadweight loss area would be, so with all of this, using these two things that we now know, 1/2 base times height. So that would be 1/2 times 50, which is from here to here, times 3, because that's the difference between 10 and 7. And that would get you $75 for the deadweight loss triangle over here. Question 6 asked what would happen if the price ceiling was lifted. And if the price ceiling was lifted, that would allow prices to go back to their equilibrium level. Because none of this would be here, so just be this X at the equilibrium, leading to an increased supply and increased demand, which would effectively eliminate the shortage, and it would result in a more balanced market where both the consumers and producers could operate more efficiently. Question 7 asks, on a market graph, create a problem that would include an effective price floor and showing the area of shortage or loss, indicating the amount supplied and the amount demanded, and the deadweight loss, and the consumer surplus and producer surplus. So the price floor is set at $3, just in this scenario, just buying a drink at the vending machine or something. And so the equilibrium price was $2, and the quantity supplied would be 150 bottles of whatever drink, like Coke or something, and the quantity demanded, let's say, is 80 bottles. And so that means that the surplus would be 150 minus 80, which would be the quantity demanded minus the quantity supplied, which is 70. So 70 bottles is the surplus. The consumer surplus up here is the area above $3 and below the demand curve up to 80 bottles. The producer surplus is the area below $3 and above the supply curve up to 80 bottles, which leaves the deadweight loss, because it was only up to that 80, so the deadweight loss little triangle over here, from 80 to 100 that's where the deadweight loss is.